Hi everyone, I'm Shubham Johar. I'm a master teacher at Vedantu. We are discussing KVPY 2018 SX Part 2 Mathematics. And the question for this video is this. The maximum possible area bounded by the parabola y equal to x square plus x plus 10 and a chord of the parabola of length 1 is. Let's explore this question. So here y equal to, you may say, x plus half whole square plus 10 minus 1 by 4, which essentially is plus 39 by 4. So this essentially becomes y minus 39 by 4 is equal to x plus half whole square. So if I change my origin to minus half comma 39 by 4, of course from 0 comma 0 to minus half comma 39 by 4, this expression would be y equal to x square. So that means effectively I may consider y equal to x square, parabola rather than taking this parabola. Why? Because shifting of origin would not affect things like length, area. Yeah. So here, now let's consider y equal to x square. And what we are looking for is the maximum area bounded by a chord of length 1 and y equal to x square. Now, by symmetry, we may say the maximum area should be bounded by that chord which is parallel to, you may say, tangent at vertex of this parabola. Why? Because, other chords of length 1 would be what? It will be like this, or let me show it this way. It will be like this, or like this, or like this. Yeah. So by intuition, we may say that the maximum possible area should occur in the case of this chord, which is parallel to the tangent at vertex by symmetry. So that means, since this, chord is of, 1 unit length, and as per symmetry, I can say this point is supposed to be half comma 1 by 4, and this point is supposed to be minus half comma 1 by 4. And this area would be what? This area would be essentially area of this rectangle minus area under this parabola above the x-axis. So what we want essentially turns out to be this rectangle has length 1, so to speak, and breadth or height, whatever you may want to say, is 1 by 4 minus integral x square dx minus half to half. Minus half to half. So what I'm saying is the area that we want is this area minus this area. That's what the area between this chord and this curve y equal to x square will be. Yep. And we have already justified why we are considering y equal to x square using shifting of origin. So here this turns out to be 1 by 4 minus 2 times x cube by 3, you may say limit 0 to half using property of definite integration. Yep. So here it essentially turns out to be what? You may say minus 1 by 4 times 1 by 3. Or you may say 1 by 4 times 1 minus 1 by 3, which is 2 by 3. Or you may say 1 by 6. So 1 by 6 is our answer. Now I believe you must be convinced about this shifting of origin thing. But you may not be very much convinced about, yaar, ye symmetry se kaise bol diya? Yeah. So let's take a general case with y equal to x square and a general chord let's consider. So here y equal to x square curve, this is the x-axis, and let me take any two general point a comma a square, b comma b square, and without loss of generality a less than b. So here what we want is, we want this area minus this area. So what would it turn out to be? It would turn out to be area of this trapezium minus area under this parabola above x-axis when x varies from, or as x varies from a to b. So this essentially becomes half times sum of parallel sides a square plus b square times height, so to speak. So it becomes b minus a minus integral a to b x square dx. So this essentially becomes half times a square plus b square multiplied by b minus a minus, you may say, b cube minus a cube by 3. So as we expand, it becomes this minus 1 by 3 times b cube minus a cube I have taken here, and half times b cube minus a cube I have taken here, plus half times a square b minus ab square I have taken here. Now as you take so half minus 1 by 3 is 1 by 6. 1 by 6 times b cube minus a cube. Let me take 1 by 6 common. So what I get is 1 by 6 times b cube minus a cube plus 3a square b minus 3ab square. Check it out. So that essentially means this expression or this area what we want becomes 1 by 6 times b minus a whole cube. Now for this to be maximum, b minus a should be maximum. Anyway, b we have taken as greater than a. And what is b minus a? If you see carefully, b minus a is length of projection of this chord on x-axis, and the length of chord is 1. So what can be the maximum possible value of b minus a? 1. It is when this chord is parallel to x-axis, then the whole chord will be the projection, and b minus a would be the maximum possible 1. Otherwise, if it is slant like this, then the projection would definitely be less than 1. Why? Because this length is 1. तो उसका projection तो 1 से कम ही होगा. Yeah. So that way you can say 1 by 6 is maximum. Even say you are not convinced still. So let me show you. What we have is a length of this chord is 1. So that means square of length of this chord is also 1. So using distance formula, I would essentially get b minus a whole square plus b square minus a square whole square, and this is 1. So that essentially means b minus a whole square you may take common, and what you get is 1 plus b plus a whole square equal to 1. Now to maximize this, I want to maximize b minus a, which essentially also means to maximize b minus a whole square. And the product of these two positive, strictly positive terms is 1. So that means this will be maximum when this is minimum. Why? Because their product is fixed, which is 1. And for this to be minimum, the minimum possible value that this can possibly have is 1. When b plus a becomes 0, or you may say, b is equal to minus a or a equal to minus b. That means b is positive, a is negative, and magnitude-wise they are equal. Modulus-wise they are equal. Yeah. So, so this will be maximum when the other factor is minimum. Factor is minimum. And for it to be minimum, b plus a whole square should be 0, taking its minimum possible value. That means b plus a should be 0. Yeah. In which case this factor becomes 1. That means b minus a whole square multiplied by 1 is 1. That means b minus a is 1. Anyway, we have taken b greater than a without loss of generality. So that would mean, let me not write now. I think it's just fine. So hence you should be convinced that the maximum possible value of b minus a is 1. Hence the maximum possible value of this area is 1 by 6 multiplied by 1, which is 1 by 6. So we have seen this thing in great detail. I hope you are able to understand and appreciate. Thanks for listening. Stay tuned for the next question.